Hello everyone, welcome to Building the Future with Cloud Native Buildpacks. My name is Ajay. I am a software engineer at JP Morgan Chase. Today I'll be presenting this topic with Rinsha, my colleague at JP Morgan Chase. She works as a developer relations engineer for our cloud platform. The agenda we have for today is to give an introduction to the cloud native buildbacks technology, to talk about its features and advantages like increased automation, modularity, security, and so on. Before going into the topic of cloud native buildbacks, I'd like to talk a little bit about the buildbacks technology itself and its history. So going back to the year 2007, Heroku came in as a platform for building and deploying Ruby applications. Many of the terms we see today for modern PaaS platform, such as 12-factor applications, proc files, etc., were actually first thought about at Heroku. Heroku eventually developed to support other programming runtimes such as Python, Java, and that essentially became the buildback technology. And then in around 2011, Cloud Foundry also started using buildbacks in their runtime, in their PaaS offering. And because there was no specification from Heroku, Pivotal Cloud Foundry's implementation of buildbacks was not exactly compatible with Heroku. So there was a divergence in how buildbacks were being developed. And with the drift towards container technology and use and a greater usage of containers in the succeeding years, we saw that Pivotal and Heroku came together for a third iteration of developing build packs, at this time with the intention of creating container images using build packs. And this is what we know as cloud native build packs today. Cloud native buildbacks are emerging as the preferred way to build applications in modern software development. So, as organizations adopt cloud native architecture, containerization, and microservices based applications, they're looking for efficient, scalable, and secure ways to manage their application builds. Traditional methods of writing complex Docker files and manual packaging are no longer used by organizations because they can be cumbersome and time consuming. So this is where cloud native buildbacks come in. They offer a simple and automated approach to building and packaging applications into container images. So the original build pack before Cloud Native build packs was a collection of scripts and configuration files that defined how an application should be built and packaged. These build packs were typically language specific and provided everything needed to build an application, including runtime dependencies, build tools, and the libraries required for the application. Cloud native build packs are a modern iteration of the build pack technology, and they are specifically designed for cloud native architecture and containerization. Provide a standardized cloud agnostic way to package applications with a focus on automation, modularity, and security. So at its core, a build pack is just two binaries. One is called detect, and it detects whether it should be part of the application building process. The other is called build. What it does is it takes part in building the runnable image. For instance, if there's a Java application that has to be converted into a container image, the Java build pack will look to detect the presence of a .java file. Similarly, for a Node.js based application, the npm cloud native build pack will look for the presence of a package.json file. And then at build time, these build packs will download dependencies as they are needed, then compile the source code, generate a bill of materials at build time, and maybe even at runtime, or they could even set the start command for the container image. You have to keep in mind that the cloud native build packs project is only a set of specifications, define rules and standards to be followed for creating these build packs. They don't themselves give us the build packs. They do provide us these rules and standards along with the orchestrator that is required for running these build packs called the life cycle. These rules and standards or these specifications are used by vendors to create build packs. Popular vendors today are Pakito, Heroku, and even Google, which is using it in its Google App Engine. So, with all this talk about build packs, they are still not usable in the form that I've mentioned so far. So, the audit collection of build packs along with the orchestrator that I called was lifecycle, and the base image in which the build happens, called the build image, is put into an entity called the builder. This builder exists as an OCI image, and this is how most users of cloud native build packs consume cloud native build packs. Now I'll get into the first advantage of using cloud native build packs. It allows more automation and increases developer productivity. With cloud native build packs, developers do not have to manually configure their build environment for their applications. The traditional way of building container images using Docker files, developers would have to first think about the instructions that are to be given in a Docker file. Then they have to think about things like security, flexibility, speed, additional software. And for all of these, are they following the best practices? So cloud native build packs take care of all of these and thus reduce the toil on the developer in packaging and building their application. This allows developers to focus on writing their code and building features for their applications. And cloud native build packs can be easily integrated with continuous integration pipelines like GitOps and Tekton. This will further streamline the software development process. So that's advantage one. Now let's now talk about the compliance of software with set standards and how hard is it to maintain these build packs. That is standardization and maintenance. So cloud native build packs provide a consistent and standardized way of building and packaging applications. So they can be easily replicated across different teams and environments. We'll think about two perspectives which will help us understand the benefits of cloud native build packs. For app developers, we've already discussed it reduces their toil in building and packaging their application. So they need not worry about how to support their application in production. For platform operators, both the container and language ecosystem best practices like minimizing the image attack surface area, handling caching, using appropriate build and runtime dependencies, and more are all handled by cloud native build packs. It also gives platform operators precise control over what build inputs are permitted and enables them to enforce policies on what application images should contain using the builder concept we talked about earlier. With that, I'll hand this over to Rinsha to talk about the other advantages of cloud native build packs.
Hello everyone, I'm Rinsha. As Ajay mentioned, I'm his colleague and a developer relations engineer for cloud at JP Morgan. Continuing on where Ajay left, we were talking about the advantages of using cloud native build packs, and I'm going to talk about the next advantage, which is efficient resource utilization. Cloud native build packs are designed to be lightweight and efficient, which improves resource utilization on your Kubernetes clusters. These build packs use a layered approach where each layer contains only the necessary components to build and run the application. This minimizes the size of the container image and reduces the amount of resources required to run the application. However, it should be noted that when a large firm offers cloud native build pack as a specification, as an offering, it will be a more generic offering, and so it may or may not be able to achieve a very small size. Additionally, cloud native build packs can be cached and reused. They reduce, therefore, the amount of time and resources that are required for building and deploying container images. Moving on to our next slide, we will be talking about the next advantage, which is modularity. So cloud-native build packs are designed to be composable, meaning that they can be combined and customized to support different use cases and application architectures. For example, a build pack for a Java application can be combined with a build pack for a database to create a complete application stack. This modular approach makes it easier to manage and maintain the application lifecycle, as changes to one component do not affect the others. Cloud native build packs can also be easily extended or customized by adding new build packs or modifying existing ones to meet specific requirements. The next advantage is, which is in fact a very important one, is security. So cloud native build packs are also designed with security in mind. In traditional methods of application packaging, there is a risk of including vulnerable or outdated dependencies, which can lead to security breaches. These build packs mitigate this risk by providing a controlled environment where only trusted dependencies are included in the application image. Cloud native build packs use a combination of whitelisting, checksum verification, and dependency tracking to ensure that only approved dependencies are used. This not only reduces vulnerabilities, but also makes it easier to keep the application up to date with security patches. In addition, cloud native build packs include features like image signing and verification, which help to prevent tampering and ensure the authenticity of the images. Finally, cloud-native build packs offer massive benefits in terms of portability. With traditional methods of application packaging, it can be difficult to move an application from one environment to another due to differences in the underlying infrastructure. Cloud-native build packs solve this problem by providing a consistent and cloud-agnostic way to package applications, which can be easily moved between different environments, much like the general build packs. Cloud native build packs are designed to work with any programming language, framework, or operating system. This is particularly useful in multi cloud environments where applications need to be deployed to different cloud providers. So, by using these build packs, organizations can therefore achieve greater flexibility and avoid vendor lock in. With this, we come to the end of our talk and hope you enjoyed this topic. We do look forward to you trying and playing around with this specification that we introduced to you, which is what we call cloud native build packs. Thank you very much.